What's going on, everybody? In this video I'm going to show you how you can make a plot in MATLAB, plot some data on a set of axes. Now there are lots of different types of plots like bar charts and histograms and pie charts and normal plots, and in this video, in this example, we're just going to cover the the normal kind of plot, not any bar charts or anything like that. We'll do that in subsequent videos. And also in this video we're just going to make a plot of a sine wave. Let's do a sine wave. Sine wave is a nice function to plot because it's got peaks and valleys and it's smooth, and so it's going to demonstrate some key concepts of MATLAB plotting very nicely. So if you think about what you would want to do, like if you were plotting something by hand, you would need to first decide on the horizontal axis. Like are you going to plot this thing from x goes from 0 to 2 pi, or are you going to go from minus 2 pi to 2 pi? And so the same thing applies here. You have to decide what is going to be your domain, I guess, but the x values that you're going to use. And so I'm actually going to use a function called linspace. And you want to be aware of this function linspace when you're making plots. And I'll explain what it does in a second, but I'm going to give it a couple input arguments. I'm going to give it negative 2 pi, then I'm going to give it positive 2 pi, and then I'm going to give it 1,000. Right, and I'm going to put a semicolon after this, definitely, because I don't want to see this vector that it returns. Now what this does is, and if we look at the length of this thing, you'll notice that it's a length of 1,000, which is this number here. What it did was it started x at negative 2 pi. We can look at x of 1. X of 1 is negative 2 pi, and then we can look at the last value. The last value is 2 pi. What it does is then it starts at the first input argument you give it, and then it goes to the last input argument you give it, or excuse me, the second input argument you give it, and it makes 1,000, or whatever that number is, equally spaced numbers in this range, right? So if we looked at x, which I don't want to do because there are 1,000 numbers there, you can imagine what the 1,000 numbers are. They go from negative 2 pi to 2 pi, and they're equally spaced. So that's going to help us plot, right? We're going to plot against this vector. Now, computers, let me back up. When you sketch something by hand, you can make a nice little continuous plot. Like think about if you were to sketch a sine wave. But computers can't do that. Computers, what they do is they plot a bunch of points, and then they kind of fill in the gaps with usually lines that connect each point. If you don't put enough points, then the thing won't look smooth. But if you put enough points, like maybe 1,000 points, the graph will appear to be smooth, appear to be continuous. So we're going to keep that in mind as we go through this example. All right, now with my x values, I have 1,000 of them. I'm going to generate the corresponding y values. And so I'm going to say y equals, and for this demonstration, I'm just going to plot the sine. So I'm going to say y equals sine of x, and that actually returns 1,000 values. It returns the sine of each value in x. So if I look at the length of y, the length of y is also 1,000. Now that's important because x and y have to have the same length in order to plot one versus the other, right? Think of these as ordered pairs, x comma y. So if x and y do not have the same length, I'm not going to be able to plot them. But they do in this case. Now I'm going to execute the command plot, and you have to put the x's first, followed by the y's. That is the horizontal followed by the vertical. So I'm just going to say plot x comma y, and then we get this nice figure that comes up there. Let me dock this. All right. Nope. I'm sorry, just give me 1 second. Let's see. How do I... Okay, there we go. So this is the figure that comes up when I do that. Now, the default figure looks okay. It looks pretty good. But we can snazz it up a little bit, and um, I can give a couple commands. Like I can tell it to turn the grid on. So you'll notice my command there, grid space on. Hit enter, and now there's this grid. I can give the horizontal axis a label. I can say X label, and then in a string, as a string, I can say like um, this might be angle, right? There it is, right? And then Y label, and I can say sine of angle, something like that, right? Y label is another command, so you'll see that that comes up. I can give it a title with the command title or the function title. This is a plotting demo, right? Something like that. So you'll see that that comes up. This looks pretty good, and I like it. I like it the way it is. But if I didn't, right? If there was something else that I wanted to change, like maybe I wanted to add a legend, or maybe I wanted to change the color of the line or the thickness of the line or the font size, there's a command actually for all of those different things, but it gets a little tedious. These are just some commands that I know off the top of my head I will execute programmatically. But if I want to fine tune this thing, I'm going to do this manually, and I'm going to click on this button up here. If I hover over it, it says Show Plot Tools. So that's what I'm going to do, Show Plot Tools. And now I can just interactively like click on the figure. I can change its thickness, right? I can change its color to red, maybe. I can change the font by just clicking on the fonts, or clicking on like one of the numbers, right? 4 or the 6, then clicking font size. Maybe I'll change that to 12, so you see it gets thicker. I can actually change the color of, maybe I don't like this gray, so I can just click on the gray and then change it to white. There we go. And I like that. So I can toggle this toggle the plotting tools on and off by hitting these two buttons. So now I'll say hide plot tools, and so now here's my plot. So that looks pretty good, right? I'm happy with that. Now actually let me open up those plotting tools again, right? And I can actually save this this figure. So I will say save as, right? And I'll save it to my desktop, and MATLAB will save this thing as a .fig file. So I will just give it a name, sine demo, and then save it as .fig. All right. And then you'll notice that at my desktop, I've got another MATLAB file here. It's got the same icon, and it says sine demo.fig. So that's really nice. It's saved now, and what I can do is I can X out of this, right? So now my figure is gone. I can clear everything, so you'll see. And now because I've saved my .fig file, I can actually load this at any point. Maybe if I want to load it tomorrow or whatever. So I can just double click on it. That loads the plot, and then I can adjust it some more. Maybe tomorrow I decide that I want it green instead, so I can change this to green. So that's really good, right? I can also go to File, Save As, and I can choose to save it as not a .fig, but as maybe a JPEG. So here I'll save it as sinedemo.jpg and click Save, and you'll notice on my desktop there is now a sinedemo.jpg. So I can open that as just any other image file, and I'll have my nice little plot there. But now notice though, or be aware anyway, that that the sinedemo.jpg cannot be just imported into MATLAB, and then you can't change the plot once you have sinedemo.jpg. You need the native MATLAB file, which is sinedemo.fig, in order to load it into MATLAB and make changes to the plot. So when I get a figure that I like in MATLAB, I usually save it as both sinedemo, or I save it as a .jpg and a .fig, right? And I would put the .jpg in like a report, right? And I would keep the fig file in case I need to make changes to that file. Now let's X out of this, and let's do the same thing, but um, let's say I go back to this command where I choose my, this was the first command that I gave. I choose my horizontal points, right? And I chose 1,000 here. Notice what happens when I don't make enough points. So let's say I'm going to graph 10 points instead, and then we'll say y is equal to sine of x. So now notice that the length of x is 10 and the length of y is also 10, right? And now watch what happens when I plot xy. And let me just dock this, dock figure. All right, this is my sine wave. And you say, well, that doesn't look like a sine wave. No. Remember that a computer, no matter what programming language you're using, a computer cannot store an infinite number of points, right? It cannot store a continuum. It cannot make a continuous plot. What it's doing here is it's plotting some points, like it's got this point and it's got this point here, and then it's connecting them with straight lines. Okay, it's just that previously you did not observe this because we had 1,000 points, so it looked continuous. Here we only have 10 points, so it's definitely not continuous. You see that there. So if you ever get a plot where you see a lot of jagged edges, the reason is because you're not plotting enough. And what you can do then, a quick fix, is just when you use linspace to generate your horizontal numbers, you just give it more points. You increase that third input argument to linspace. All right, so in the next few videos, I'm going to show you how you can make some different plots, like a logarithmic plot or a bar chart or a histogram. So I will see you then. Thank you.